Hi and welcome to Enfield Physics Tutor. Today we're going to look at a difficult capacitor question. Don't forget to subscribe, there's over 100 videos now waiting for your perusal. We're given the peak voltage of 15 and asked to calculate the root mean square voltage. This is simply the peak voltage divided by root 2, 15 over root 2 or 10.6 volts. Next we have to find out what the Y voltage gain of this oscilloscope is. Well, we know this top point is 15 volts and this obviously is going to be 0. We therefore have three large squares going from 0 to 15. Therefore one division is equal to 5 volts and so the gain is equal to 5 volts per division. 4.3 asks us to show a line on the graph which has the same rate of energy dissipation as the sine wave. Well, of course, that's what the root mean square voltage is. So in other words, we need to draw a line at 10.6 volts, which is pretty hard to do on a computer screen. 4.4 asks us to find the frequency of this wave given the time base is 1 division is equal to 5 times 10 to the minus 4 seconds. So we just simply count off how many squares or divisions there are in one complete cycle, which in this case is 8. This therefore means that the time to travel 8 is going to be equal to 8 times 5 times 10 to the minus 4. We know that frequency, of course, is 1 over period, and so we get a frequency of 250 Hertz. The last part of this question is one of those questions where they just take you a bit further than the syllabus and ask you to sort of apply your skills and knowledge. We have a resistor and a capacitor connected in series with a square wave generator, as we saw in the previous question, and we're measuring the voltage across the capacitor. So in this case, the capacitor is charging up and discharging multiple times to produce that rather beautiful wave shape that you can see in figure 10. We can identify in the curve the charging section where the voltage is increasing or ramping up and the discharging section. Now mathematically speaking, I always find the discharging section is easier to handle, so that's the formula we're going to use. A way to use these formulas is to remember that we can set V and V0 to pretty much anything we like on the graph and read off the difference in time between those 2 points, thereby enabling us to get the value for RC. Let's put this into action and rearrange the formula to give us V over V0 equals e to the minus t over RC. We know that V0 is 15 volts, that's the maximum voltage. So let's set V equal to 7.5 on the graph. You can see I've done that with the horizontal of the red lines. At this point, V is 7.5 and V0 is 0, which gives us V over V0 is a half. And of course, that is still equal to E equals minus T to the RC. Now we can drop a second line down to work out what the time is at that point, which is going to come out as around about half a division. One division being 5 times 10 to the minus 4 seconds. We therefore know that the time at this point is going to be 2.5 times 10 to the minus 4 seconds. And that is our value for RC in this version of the equation. Therefore, let's take logs of both sides. So log of half is equal minus T over RC. Rearranging that, we then get that minus T over log of half equals RC. We know that T is equal to 2.5 times 10 to the minus 4. Of course, I need a minus in there really, over log of half. And when you bung that lot into your calculator, you will get that, because the log of half is negative, we will get a positive value, which is going to be 3.6 times 10 to the minus 4 seconds. So that's the value of our time constant. Realistically though, can we even justify two significant figures here? Probably not, especially when you're trying to do this on a computer screen. I hope that was helpful for you. Don't forget to do all the usual subscribing blurb that you have to do on this YouTube thing.